Welcome to solverfy.
So in this problem, we are given with the reaction of an iron ore which has a formula of Fe2O3 and that is reacting with carbon monoxide and to produce iron and CO2. So in first part of this problem, we have to balance this reaction. For balancing, what we'll do, we'll first write down each species which is present in both sides of the reaction equation. So in reactant side, we have FeC and O, and we have also FeC and O in the product side. Now we have two Fe in the reactant side. We have one carbon, and we have 3 plus 1, total 4 oxygen. The product side, we have one iron, we have one carbon, and we have 2 oxygen. Now first we will balance our metal, which is iron. So we have 2 iron in reactant side but 1 iron in the product side, so we'll place it 2 here to have 2 iron in this side also, in the product side. Now we have 2 iron in both side and we have 1 carbon in both side. Now we'll balance our oxygen, so we have 4 oxygen in the reactant side but we have 2 oxygen in the product side. That means we need 2 more oxygen in this side of the product side. So what we'll do, we will multiply this CO2 by 2 to have 4 oxygen in the product side. Now we have 4 oxygen in the reactant side and 4 oxygen in the product side, but at the same time we have changed the number of carbon in the product side. Now we have 2 carbon in the product side, but we have 1 carbon in the reactant side. That means we have to place a 2 here to have 2 carbon in the reactant side also. But again, we have changed the number of oxygen in the reactant side. Now we have 3 times 3 plus 2, that means 5 oxygen in the reactant side. Now we need more oxygen in the product side, but we cannot have 5 oxygen in the product side since the number of oxygen we can have here is the multiple of 2. So what we can have here is 6 oxygen. So we can place a 3 here to have 3 times 2 will give us 6 oxygen. So now we have 6 oxygen in the product side, but we have 5 in the reactant side. That means we will have to place 3 here also, which will give us 6 oxygen in the product side also, in the reactant side also. And we have 3 carbon now in the reactant side, and we have 3 carbon in the product side. That means now we have 2 iron in each side, we have 3 carbon in each side, and we have 6 oxygen in each side. That means this is our balanced reaction equation. Now in the second part, we have to find out the number of grams of CO that can react with 0.35 kg of Fe2O3. So what we will do is, first we have to find out the number of moles for 0.350 kg of Fe2O3. So 0.350 kg means 350 gram. 350 gram Fe2O3 is in number of moles of 350 over the molar mass of Fe2O3, which is 159.69 gram per mole. It is 350 gram, and it will give us a value of 2.192 mole. So this is the number of moles for 0.350 kg of Fe2O3. Now we have to find out how many mole of CO uh, will react with this much mole of Fe2O3, and from there we can find out the grams of CO that will react with this much gram of Fe2O3. So from the reaction equation, we can see that 1 mole of Fe2O3 will react with 3 mole of CO. It means 1 mole Fe2O3 will react with 3 moles CO. That means this much mole of Fe2O3 will react with um, 3 times 2.192 mole CO, which is equal to 6.575 mole CO. And if we just multiply this by the molar mass of carbon monoxide, we can find the mass of this much mole of carbon monoxide. So the molar mass of carbon monoxide is 28.01 gram per mole. So it will give us a value of 184.17 gram CO. That means this is the gram of CO which will react with uh, 2.192 mole or 350 gram or 0.350 kg of Fe2O3. Now in the third part of this problem, we have to find out how many grams of Fe and how many grams of CO2 can be formed from 0.350 kg of Fe2O3. Second, we have find out the number of moles of 4.350 kg of Fe2O3, which is 2.192 mole. So we have to find out how many mole of Fe and CO2 can be formed from this much mole of Fe2O3, and from there we can find out how many grams of each of them will be produced. So first we'll find out how many moles of Fe will be produced. So from 1 mole of Fe2O3 we can find out, or we can form 2 mole of Fe. That means 1 mole Fe2O3 can produce 2 mole Fe. That means 2.192 mole Fe2O3 will produce 2 times 2.192 mole, which is equal to 4.386 mole Fe. And if we want to find the mass of Fe, we just simply multiply this number of moles by the molar mass of Fe, which is 55.84 gram per mole, which is equal to 244.91 gram Fe. So this is the mass of Fe which will be produced from 0.350 kg of Fe2O3. Now we'll find out how many grams of CO2 will be produced. So from here we can see 1 mole Fe2O3 can produce 3 mole CO2. That means 1 mole Fe2O3 can give us 3 mole CO2. That means 2.192 mole Fe2O3 will give us 3 times 2.192 mole is equal to 6.575 5 mole CO2, and if we just want to find the mass of CO2, we just multiply this number of moles by the molar mass of CO2, which is 44 gram, and it will give us 289.3 gram CO2. So this is the grams of CO2 or mass of CO2, 289.3 gram, which will be produced from 0.350 kg of um, Fe2O3. Now, in the last part of this problem, we have to show the calculations in part B and C are consistent with the law of conservation of mass. So, law of conservation of mass is the mass of the reactants reacting will be equal to the mass of the products produced. So, the mass of reactants reacting here is 350 gram of Fe2O3 is reacting with 184.17 gram of CO. So the total reactant here is 184 point so the total is 534.17 34.17 gram, and the products produced are, we are having 244.91 gram of Fe and 289.3 gram of CO2. So the total products are 534.21 gram. So you can see that the mass of reactants is almost similar to the mass of the products which is produced. That means the calculations in part B and C are consistent with the law of conservation of mass.